Well, hey Jesse, thank y'all so much for letting me come on and do this webinar. I really enjoy doing stuff like this. My name's Larry Stanley. I live over here outside of Nashville, Tennessee, and I've got 30 plus years into drives and soft starts now. And a lot of the stuff here is just stuff that I've kind of gleaned through the years and tried to make note of, and just from my past of working and troubleshooting drives a whole lot. When we start talking about troubleshooting drives, Jesse, or any time we're ever working around something like that, the very first thing before we think of anything else, I want everyone to think of safety. Now, Lord knows I absolutely despise somebody to read me the words that's on a PowerPoint slide. I'll tell everybody all the time, I can read as good as anybody else, it just don't sound like it. But this is the one that I want to read to you. When you're talking about sending somebody out to work or service a drive, we need to make sure that's a qualified person or the right person. And I get that word qualified from NFPA 70E. And that person is somebody that's got skills and knowledge. They know how the drive is constructed, and they know about the equipment itself and the installation. They've had some safety training, and they kind of know how to avoid the hazards. And I'll bring this up as in a perfect example is about 2 weeks ago, I had to go to a job site over at College Station, Tennessee. And their user over there at a little remote lift station was working on a panel that had been built over by a very reputable firm, but they had bottom fed the breaker. And for some reason, he didn't realize that breakers could be bottom fed. And they had a problem because he didn't realize that. So without getting into all the ugly part of it, I thought, that's the perfect example of that qualified person. This gentleman was a good guy, but he really didn't know everything that maybe he should have known. So if you're a manager out there, if you're a person of charge and you're the person that's taking care of getting people to the job site, make sure that you do have that qualified person going out to that job site. It's important. When we start talking about a variable frequency drive, we want to disconnect all our power sources. And you've got to really look at that. You've got to understand that maybe it's not just the three-phase mains or the single-phase 230 volts that's coming into it. We might be switching 120 volt on a drive fail relay somewhere, or you might have 120 volt on a drive run relay. So even though you got your mains disconnect open, you might have the fuses pulled, you might still have voltage in that cabinet from a secondary source. You need to have a lockout tagout procedure. For me, that's critically important. Lockout tagout keeps everyone safe. It keeps your people safe. It keeps the user safe. So make sure that you have a lockout tagout procedure. And as much as I can, this is not a wink, wink, nod, nod thing. It's not, oh my gosh, I'm in a hurry. The kids, I got to go get, my wife needs me to pick up this before I go see the soccer game, and this is going on. No, nothing comes before this. Once you have that lockout tagout procedure in place, you always go through your lockout tagout procedure. And I'm here to tell you the most valuable thing that you can ever do is leave work and go home to your family. So follow your lockout tagout procedure always. Use a voltmeter. I like to have, when I'm thinking about a circuit breaker just like this guy over in College Station, I tell the guys all the time, look on both sides of that breaker, look phase to phase and phase to ground. Understand what you're looking at, okay? And also remember, there's capacitive energy that's stored. We're going to talk just a tiny bit more about that. With a variable frequency drive, it's hyper critical that you remember that an open circuit breaker, an open disconnect, you can pull the line fuses. It does not matter. It does not mean that DC bus is not 100% charged, even with the disconnects open. If you're looking at a 460 volts main, you're talking about a minimum of 650 volts DC. It will knock you on the ground and you will cry like a broken-hearted schoolgirl. If you ever get your hands on that DC bus, it'll be the worst thing that you ever face, buddy. It's horrible, horrible. On all the drives, ABB, Cutler Hammer, Square D, we're not talking about trade names today. We're talking about drives, okay? On all drives, there's a DC bus indication lamp. It just says a little lamp that comes on that says DC bus charge. And you would think that when that light goes off, that okay, the bus is no longer charged. If you're going to be the person that's putting your hands inside that drive, assume that that circuit has failed. You want to have a meter and you want to know how to use the meter. You want to look between your positive and negative bus and make sure that you don't have a charge on your DC bus. I kind of joke and I'll tell people, if you don't smoke, it's a good time to start. Turn the drive off, go out and have a smoke, come back in, check your bus. You need to give it 2 or 3 minutes, sure enough. Let the DC bus discharge. If the bus is not discharging, we've already identified one of the problems, okay? But we should see the bus discharged to at least below 50 volts DC under 2 minutes. 50 volts DC is still a nasty little shot. So I like to watch and just make sure that my bus is discharged before I get my hands in there and start working with the drive, okay? That, to me, that's the smartest thing to do. You know, today we have the Bluetooth keypads, just the keypads in general. I started out with the drives, didn't have any, they had blinking lights sometimes, and that was great if you even had that. And then the old analog keypads, and today now we have some nice new things like that, like the Bluetooth keypads. Bluetooth is wicked cool in that now I can leave that door, that enclosure closed. When I was a kid coming up, we'd always start our drives up, and I always carried at least 2 clamp-ons. And I like to put a clamp-on on 2 motor leads. And I would start my drives up really, really slow. I'd bring them up from 0 speed up to full speed, and I might give it a 30-second or 45-second ramp. And I like to watch that amp probe and just see what was going on. Because if I saw something bumping really bad in current, I knew that most likely it was something going on in that application. And I would make note of that on my startup reports, okay? Now, I don't have to do that. I don't have to open up that door and put clamp-ons on the motor leads. I don't have to stand there in front of the door open, you know, and reaching around the backside, increasing the speed of the drive with a speed pot or something like that. I can leave my doors closed. I remove myself or my person from that arc zone because my door is closed and it's bolted down. With the software that we have with the 580 products and the 880 products, now we can plot motor speed against motor current, and I can actually look at T1, T2, and T3. And that's pretty cool. I like to do that. I think of it as kind of like almost a mega check. You know, if I'm out doing a new startup and I can look at what my speed is doing, and right directly below that, I can watch my current. And if I see that track all the way through and my current comes up nice and smooth and I'm not seeing spikes, then I know that I'm not getting a lot of mechanical resonance or something happening in the pump or something happening in a fan or on a conveyor for that matter. I know that everything is coming up smooth. I like doing that. And then I can actually store that. So now I know when I commission this drive that it commissioned well and my current come up nice and smooth. If I'm out there commissioning the drive and I start seeing these issues, I can go to the owner right now and I can say, look, man, this is what we're seeing with this pump and motor or this fan and motor or this conveyor and motor. This is what we see regarding current. And we can absolutely relate that to the load then. The neat thing about the Bluetooth is we don't have to use an iPhone. We could use an iPad or another smart device. I use my iPhone most of the time because it's just what I've got in my hand. I don't necessarily like to carry my iPad into a lot of and I'm kind of a water kind of guy, so I don't like taking my iPad into a waste water treatment plant if I can help not to do it. But I've always got my iPhone in my pocket there, so I'll have my iPhone with me. Your Bluetooth device can be connected up. I've done it at least 100 foot, and it worked like a champ. So this says 246 feet. I have no doubt that it wouldn't work at 246 feet. No doubt whatsoever. If you're using this, using the app, we just upgraded the app that you download. So you'll want to go back and upload or download the newest app and everything there. That would be something you might want to consider doing. okay? And like it says right here, you can bring whatever device that you want as long as it's a smartphone. When I think about troubleshooting a drive, I think about all the years that I spent troubleshooting drives, and I was the guy that sat on the other end of the phone. Me and a fellow named Dave Jeffcoat, one of the best men in the world. Okay, Dave Jeffcoat and I started the drive support team for Square D back in 1985 over in Columbia, South Carolina. And I think about the questions that come in, and and I love that job because it was like putting a jigsaw puzzle together over the telephone, and it was really a lot of fun as long as you ask the right questions. And when I start troubleshooting something, especially if you're not the guy in the field, if you're interfacing with that person in the field, there's some basic things you want to know. You want to know, can you not hear me?
We're okay. You're
okay.
going.
All right, that's spooked me. Sorry about that, Jesse. So you want to know, one of the very first things that you want to know is, how long has this drive been installed? Is this a brand new startup, or has this thing been out there running for 3 years or 5 years or something? Because the length of time is going to take you down all kinds of different paths of troubleshooting. Okay. So you want to know how long it's been installed and running, and has it always been functional? Is everything going? What's going on with it? What's my environment like? When I went onto a job site, I always looked at the enclosures. Looking at the enclosure tells you a whole lot, and I'm speaking of the old enclosures on the job site. Look at them. If you see a place where they're all scratched up or something, that's a good thing kind of sometimes, because now I can look and I can see if the metal is corroded, okay? I use my nose. I think the Lord gave us one of the best troubleshooting tools in the world when he stuck that nose right on the front of our face. When you walk into a job site and it stinks, you know something's going on. Hydrogen sulfide stinks. I mean, it doesn't go unnoticed. Chlorine stinks. It doesn't go unnoticed. So I like to talk about the environment of what's going on around the drive. I like to look at my actual application, okay? If it's a pump, a lot of people are in a bad habit of using the word pump and they stop talking. Now, is it a centrifugal pump or is it a positive displacement pump? Now, a centrifugal pump, something that goes roundy, that's a variable torque application. I don't need a whole lot of current, and basically I don't hardly need any current to move a variable torque load off of 0 speed. But now if I'm a PD pump, a piston pump, positive displacement pump, then I need constant torque drives. I need 150% overload for 1 minute to get me up and running. So I like to know what kind of pump it is. That's very telling. Or I like to know, am I on a conveyor? Am I on a screw? What's the actual application? What are we doing with this thing? If the drive is tripping, give me the fault message, common sense. What does the drive think's going on? Okay. And then you have to think about it yourself. Well, does that make sense? Is the drive trying to tell me one thing and maybe I know this is going on? If I'm in the plant, I like to know, does anything else go down? Is there some other heavy load that's starting across the line? I've had applications in the past where we had a line going down. It was on it was called a rubber roller. It was a piece of equipment that rolled the rubber lining that goes inside of tires, and the drive would trip just every once in a while. And it was associated. We finally figured out it was associated with an overhead crane, and the collector shoes had where they had bounced on the rails so many times. There were some pits on the rails, and the collector shoes on that crane was arcing some, and that was causing an electrical issue, and the drive was seeing it. So there's all kinds of things like that can happen as you're troubleshooting the drive that you need to try to make yourself aware of as you're going through. I think grounding is one of the most underestimated things that we have with the drive. When you ground your drives, make sure that you're getting a good ground on each drive. You absolutely, positively cannot daisy chain. Cannot. You're going to be picking up noise from one drive and dumping it right into the next drive. That's not allowed. You can't do it. I was on a job when I was at Square D in Greenville, Mississippi. Well, it's not out in the middle of nowhere, but it's way down there in Mississippi. It's down in the Delta country. and it was a big warehouse that put together packaging for a major retailer. They were having all kinds of problems. They'd put in all these drives on a Profibus ring, and it just was not working, man. It was pretty bad. And then after they'd spent some time trying to get it up and running, I got a call to go down there. And when I went into the job site, the first thing that struck me is they had the drives mounted on 4x8 sheets of plywood, 3/4-inch plywood, and they'd use muffler clamps to clamp the plywood onto the handrails of a catwalk. The ground wires were daisy chained from drive to drive, and then they had cut a spot on the handrail and had grounded on the handrail of the catwalk, and it was a mess. It was just a mess. There's not a whole lot you can do with that. You need to have a good ground plane. I always like to think and laugh, and I say that my ground is my foundation. Just like when you build your house, when you build your business, you start with a mechanical foundation, you start with a financial foundation, a spiritual foundation. You know where you're at in your life, you know what's going on. And a drive, its foundation is its ground. So we have to be well grounded. We have to watch what we're doing there. When we bring the ground wire back from the motor, this is just kind of for fun. That's an old Altivar 61 or 71 on that left-hand side there. I just did that because I was just goofing a little bit. When we pull our ground wire from our motor back, we want to pull the ground wire in unbroken ground from the motor back up to the drive. And we want to land that on the PE lug of the drive, potential earth, okay? And that way, if I've got any common mode, not if, that way the common mode voltage has a chance of moving back from the motor back to the potential earth, to the earth ground, and we can send that common mode voltage back out to the distribution. So that's important. We get it back to the neutral of the distribution anyway. So that's something I like to always recommend when we're talking about the ground wires. Don't undersize the ground. Don't think that ground wire out at the pecker head down to the capstan is all you need. No, we need to have 4 wires going back. We need our motor leads and we need a ground lead. Okay, and that ground wire needs to go back unbroken. Okay, when we're talking about cable routing, all right, we want to make sure that we're following the manufacturer's recommendation. The hardware manual is your best friend, okay? If you're putting it in cable tray, make sure you're keeping good segregation on your motor leads. Make sure that you're mixing your motor leads correctly. Don't run all of one phase in one section and all of B phase in another section, and C phase or T3 in a third section. Don't never, ever, under any situation, ever mix control and power wire. I got involved with a really nasty job down in Decatur, Alabama, at a chicken plant, and they had motor control centers with drives, and they had run all the control wire. They had actually pulled the control wire of the motor leads. They had mixed multiple motors. They had in one set of conduit, they had 11 motors in a conduit. I got involved when the electrician went out to change out, and it was in a washdown section of the plant. I got involved when the electrician went out to replace a motor. He opened the disconnect, thought everything was safe, did not use his meter, and when he opened the pecker head, he took a pretty nasty little shock. He had about 235 volts on the motor lead, and it was because of inductive coupling between all the other drives that was running. And I got involved on that job because of that. They had so much inductive coupling into the control section, you could walk up to the drive on the motor control center side, you could hit the stop button and the keypads would clear up and the motor would stop. When you took your finger off the stop button, 3-wire control, you took your finger off the stop button, the drive would start back up. There was enough induced current there to actually keep the control circuits hot all the time. It was a mess and we had to fix it, okay? Those are the kind of things that you want to watch out for. You want to realize what's going on. You can, when you're crossing your cables, keep them at a 90-degree angle. Keep that crossing as short as you possibly can. That'll save you a whole lot of heartache right there, okay? Your output cable length, okay? that you need to talk, you need to look and see what your manufacturer says about that. In general, I tell my little guys, my 10 horsepowers and below or 20 horsepowers, I want you to be well under 100 foot, about 75 foot. Okay, don't put 300-400 foot on a little bitty drive. Now that could be very problematic. When we get into bigger drives, and we can have some longer distances. Okay, there's a couple things that we can do there. We can use a DVDT filter. Sometimes you might even have somebody that recommends a sine wave filter. Sine wave filter is fine, but just remember, sine wave filters are expensive. They're not cheap, and they're not little bitty guys. They're a good sized piece of equipment, and they're almost like having another drive there. So now you have your drive sitting there producing heat, and you're going to have your sine wave filter there producing heat, and you've got to take into account all that heat that's generated. Sometimes we might use nothing but a load reactor in the output of the device. As a general rule, I kind of like a DVDT filter. It puts a fairly low amount of impedance in that output circuit. And we also have a low pass filter. We have a capacitor and a resistor in there. And it really helps clean the top of the PWM waveform up. It really looks good when you look at it with a scope or something. So I kind of lean towards a DVDT filter in the output of the drive when I know I'm going to have a longer motor lead. How do I know when to use a motor lead? How do I know when to use a DVDT filter? There's a couple things that just jump right out at me. If I've got an application and that motor is going to be harder than ATs to get pulled, then I'm going to put a DVDT filter in there. I'm going to do everything I can to protect that motor. If I have an old motor that's got 3 coats of green paint on it, and you got to take your pocket knife and scrape the crap off the top of the nameplate, but it's still running, I'm going to use a DVDT filter, because you don't have any idea in the world where that motor is in its lifespan, and you want to protect that motor. Okay, so those are some of the things that I think about when I start thinking about a long motor lead, and I start thinking about DVDT filters or sine wave filters or load reactors, something along those lines. Okay, so that's where I go to there. I think one of the most common things that I ever got as a troubleshooting question is I'm telling the drive to start and it's not starting. Every once in a while, we might get somebody call in and say, I've got the drive started and it's not responding to my stop signal. That happened too from time to time. And there's a couple of things that we need to do. And I can tell you, with the generation of drives that we have in the marketplace today, we really made troubleshooting this a lot easier, okay? So one of the things that I think about on the new drives, especially the ABB drives, is we have the ability to put safe torque off. Now, in the industry that I typically serve, I typically work a whole lot in the water industry, okay, today. And we really don't talk about safe torque off in the water industry. But what we do talk about is we talk about e-stop. And this safe torque off, what it gives you the ability to do is to shut the IGBTs down in the output of the drive. And that's another way of us developing a e-stop circuit if we want to, okay? So that's the kind of things that I think about. I think about, is there any chance that somebody has tripped my safety interlock circuit and the drive is not starting? Do we have the drive set up for 2-wire or 3-wire control? Does the drive require a rising edge? Was the drive running and power went down, and now I'm gonna have to cycle the start command before it starts back up? Okay, those, I think about that. I've seen issues like that. I look at the contacts. It's not a bit uncommon that we see people on the wrong side of the contacts. Okay, that's actually fairly common. And then the other thing to look at is, am I actually receiving my analog? Well, the drives that we have today, and I know ABB has it, and I suspect some of our competitors have it too. We have a really cool I/O map, inputs outputs map, and it's built right there into the keypad of the drive. And you pull up your I/O map, and it's going to tell you what your inputs are programmed for, and it's going to tell you whether that input is high or is the input low. It'll give you a 1 or a 0. So when you start troubleshooting something like the drive is not starting, look at your I/O map and let's just look and see if the drive thinks it's being told to run, or it knows that we've got an analog coming into it. That's one of the neatest things in the world for troubleshooting a drive. Really cool feature that shouldn't be overlooked. I think a common trip in the water industry and the HVAC industry, definitely on the industrial side, is drives going down on over temperature. It is absolutely a common thing to have happen. I've been on so many job sites where this is an issue. It's hard for me to even think of a good one to talk to you about. But in my water world, and I'm sure in a lot of the other segments, one of the things that we see specified very often is filter kits on the front of the drive enclosure. And I love filter kits. I think they're a great idea. Okay, but along with that filter kit, we need education and maintenance. We need to know that that filter is there for a purpose. It's there to get dirty. It's there so that we don't pass that mess inside the drive cabinet. But once that filter starts doing its job, it becomes blocked. And we need to know that we're pulling that filter out, or we're testing that filter on a religious basis. You know, it's got to be. Otherwise, we can't get the cooling air into that drive to help displace the heat out of the drive and exhaust the heat out. So the heat sink kits with the filters, I like them a lot, but man, make sure that you're checking them. Okay. Now, when I look at filter kits, one of the things, if you're the person that's going to be specifying, you want to make sure that your filters are on the outside of the drive enclosure. You do not want to open the door to change the filter. And as crazy as that sounds, there are companies that actually put the filter on the interior side of the door. Okay? That filter should be on the outside for a couple different reasons. But first and foremost, if I leave my door shut, I remove my employee out of the arc flash zone. Okay, that door is shut and bolted closed. Now there's no reason for him to open it to change the filter. The other thing is, if I open that door and I'm pulling the filter out, now I have the potential for dropping that filter, of putting more mess inside the cabinet. So make sure that if you're the specifying person, that you specify your filter kit to be applied outside of the door. Okay, and that'll save you a lot of issues there. Naturally, the cooling fans, you want to look at that. Through the years, one of my habits that I've gained, especially back when I used to, well, even today, I shouldn't say that, even yet today, if I'm walking across with a lineup of drives, I might put my hand up, or I absolutely try to notice if I feel air coming out of the top vent. As you're walking through, if you've got 6 or 10 drives or whatever it is lined up in a row, and you have air coming out of them, and you step inside the front or step in front of one of them, and there's not air coming out of it, then you know, hey man, when I get ready to pull maintenance, I need to check this thing. You might even want to go look on your keypad and see what your temperature of your drive says it is. Notice stuff like that. I might even take and run, or not might, most of the time, I'll take and put my hand up on the front of that drive enclosure and just try to notice what the fan is, try to notice what the temperature of the enclosure is about. All of our drives enclosures are rated for 40 degrees C. Your body temperature is about 96. Okay, so you should be able to feel real easy with your hand if you've got a heating issue there. Okay. And I'll run my hand across the front. Now, one of the things I want to caution you on, don't use compressed air to blow the drive cabinets out. You might be tempted, don't do it. Now, you might blow that drive cabinet out and step back and put your hands on your hip and say, look how nice and clean that is. No, it ain't clean. You just can't see the dirt no more. It ain't not a bit of difference in the world in flipping that kitchen rug back and sweeping all that mess underneath the rug and turning it back down. You don't see the dirt because you have blown the dirt and the debris behind the boards. You've not cleaned anything. And one of the worst things that could happen in this is that we had heavies or metal shavings that were heavy enough to stay in the bottom of that enclosure until you put that compressed air in there. And now you've lifted those heavies up and they're going to settle back down into the drive somewhere. That you absolutely do not want to do, ever. Okay? Now, not to talk out of the other side of my mouth. It might sound like it, but I promise you I'm not. If the heat sinks come out the back of the enclosure, you could use some low pressure air, compressed air, to actually blow the heat sinks out. I was on a job site in Florida with a guy named Mark Reith. He's on a egg farm. Never been to one before. Pretty awesome, I guess is a good word. I went in, they had a drive problem. They had mounted the drives again directly on 2x4s in this great old big chicken house, and the enclosure consisted of a piece of tarpaulin. They had rolled a 2x4 up, rolled it up in a 2x4 on the top, nailed it to the wall, rolled a 2x4 on the bottom, used roofing nails to nail it onto that 2x4, and then nailed the 2x4 to the wall. That was the enclosure. Mark and I got to the job site, pulled the cover up on it, and the drives were cankered full of chicken stuff. And it was feathers and chicken poop and just everything that you could not want to imagine. And the drives were cankered full of it. Now, that serves two different problems. Well, first problem, the most obvious, is if the heat sinks can't breathe, I can't get the heat out of the drive, and the drives are going to go down on a thermal condition. In that instance, that chicken poop that was there, it's corrosive. It's going to eat the drives up. It's not something you want. So that would be a great installation for us to put a type 12 enclosed drive onto that job site. Okay, so those are the kind of things I've seen when I'm thinking about cooling issues. Oh, another thing to remember about the fans, not just ABB, lots of people. When you shut the drive down, those cooling fans are going to continue to run. We want to bring that heat sink temperature down to a certain level, and the fans will run until we reach that level. So if that's happening, don't be alarmed about it. It's okay. That's what you should be looking for. That's something that probably should be happening. Input phase fault, a very common thing. Just kind of look and make sure that you've got all three phases coming in. Now, one of the really cool things about the ABB drive, we might not necessarily trip on input phase fault if we have a momentary input phase fault, because we're not stressing the DC bus of the drive. That's a nice thing. Think about it like this. You've got a remote station of some kind somewhere. It doesn't matter whether you're a remote lift station with a sewage system, or you're in a 40-floor building with an HVAC system in the top of it. You don't necessarily want that drive to trip if you have a momentary outage. You want the drive to be able to continue to run as long as you're not stressing the DC bus of the drive. You're not providing anything that's going to damage the drive. So we can do that. It's not hard to do it all, okay? You can look for different things if you're having it as a nuisance. When you swing the door of the drive open, I like to look at the fuse clips. Fuse clips are typically nice and shiny. If they got this old gunmetal blue color on them, then we need to start thinking, well, why is that? What could cause that? Well, I think about things like the heat. Is there some reason? Have we lost the tension in the fuse clip? Do we have a harmonics problem? Have I got a higher do I have a higher current level on that leg for some reason? What's causing me to have this discoloration on that fuse clip? Okay, look for something discolored. Is it chemical? Okay, is it biological? Are you out on the coast somewhere and I have salt air and that's causing my problems? Okay, with my connection. Those are the things that I think about on input phase loss or an undervoltage. It's not necessarily just the power that's coming into the drive. It might be what's associated with getting the power into the drive. Have a meter, know how to use your meter, check your meter, verify your meter. Verify, measure, and verify, okay? 3 times. Let's look and see what it says. One more time here. If you're the person in the field, remember, breakers don't have a top and bottom. There's not an input and output side. A breaker can be top fed or it can be bottom fed. Be aware of that. Be cognitive of that, okay? I know that on the larger square D enclosed drives, all of those drives, the breakers are bottom fed. So remember that. If you're the person out there working with this drive, if you're the person in the field with a meter and putting your hands inside here, just remember for sure that breakers are not required to be top fed, okay? We can also, on the ABB drives, especially in a fan condition, or an application rather, not a condition, but an application. If we want to, we can manage the DC bus with the mechanical load on that fan. If we have an outage take place and we have the drive set up, and it's easy to do, we could actually let the loading on the fan keep the motor shaft moving. If the motor is moving, as long as I can keep that shaft moving slightly faster than the rotating field, then the motor is a generator. And I can use that kinetic energy in that fan to keep the drive energized through the motor and waiting for the mains to come back up. And then the drive will pulse out, it'll look at the motor and see where it's at, and it'll either catch the motor or it'll stop it and bring it back up to speed. That's something that's really cool when you have a fan load. A pump, not so much, and a conveyor belts, not at all. But fan load, something that I can have an overhauling load on, works pretty darn nice, okay? Those are the kind of things that I think about. Output phase loss. One more time, your meter is your best friend, okay? Now, if you're looking at the output of a drive, if you're going to want us to have your drive running, I typically tell people to run the drive up to at least half speed, okay? And I want to look at my output voltage phase to phase, not so much phase to ground, but phase to phase on the output of my drive. With some meters, depending on the type of meter that you're holding in your hand there, or you got setting on your table or whatever, you might notice that your voltage is higher than what you're expecting. What you want to watch for is you want it to be balanced. If you're at about half speed and you're seeing 312 volts or 320 volts, T1 to T2, then you want to see the same amount between T2, T3 and T1, T3. Where we are voltage sourcing current regulating drives below 1,000 volts AC. And I think everybody is. I don't think there's any exception to that. I think we're all voltage sourcing current regulating drives. So what we really mean there is our voltage is going to be pretty darn steady coming out of that drive. And if it's not, then we know we got a drive problem. Probably one of the better troubleshooting tools in the world is to look at the output voltage coming out of the drive, okay? And we want to see a nice balance between the motor leads. Drop the motor leads as close to the drive as you can, okay? If you have a bypass, and I've seen this happen several times through the years, with a bypass mechanism, you're going to have an isolation contactor and a bypass contactor. That isolation contactor prevents you from backfeeding the output of the drive when you're running in the bypass mode. So that output contactor or the isolation contactor is going to be open to isolate the output of the drive from the voltage from the bypass contactor. A couple times I've actually seen a couple problems with this. It's not uncommon that we might lose a control fuse and we're not able to bring the isolation contactor in. And it all depends on how your control circuit's made up. And we might get an output phase loss, okay? I've also seen that isolation contactor bounce. And that typically causes an instantaneous overcurrent trip if that contactor bounces any at all. I've actually seen that in a very large HVAC application at Baptist Hospital and over here in Nashville, Tennessee. Paul Dixon is the guy that runs that, or I guess he still runs it. I haven't talked to him in several years now. But we had an application over there, and they had put a Hawkeye relay in and had sequenced it back into the control circuit. And this Hawkeye relay had failed, and that contactor was bouncing. It sounded like a machine gun. It was bouncing so hard and so fast. But that would have caused the drive to trip on instantaneous overcurrent. And that was a little bit of a mess for us to go in and figure out, because that Hawkeye was not on their control drawings, and we just actually had to find it inside the enclosure, okay? So if you do have bypass, let's make sure nothing's going on with the isolation contactor there. If you do have bypass, historically, when I started up a package, a drive bypass package, I always like to bump the package in bypass first and just notice the direction of the motor. Then I would bump it with the drive and make sure the motor is running in the same direction in bypass and in drive. Really important, okay? And here, just remember, you can roll the input to the drive until Gabriel blows his horn and calls you home, and you will never rotate the direction of that motor. With a variable frequency drive, you have to roll motor leads to reverse the direction of the motor. You can go in and you can actually reverse the direction of the motor in the software of the drive, or you could just use the reverse bit to start it in reverse instead of forward. But you cannot roll the input leads on the drive to reverse the motor direction. Okay, and that doesn't matter what drives out there. That's true. I've had at a Scottsboro, Alabama, at an aluminum plant. This is back when when the Baldor drives were still here. This is 9 years ago. We had an issue. The user would put a disconnect at the motor, and the electrician would go out and open the disconnect and close the disconnect at the motor, and it would trip the drive on instantaneous overcurrent. Well, today's drives, the IGBTs operate so fast that if you do close that disconnect, we're not really worried a lot about destroying the IGBTs. It's not a good idea. It's a bad work habit as far as I'm concerned. But the drive is going to shut down really, really fast. Okay, but just the same, it's not a good idea to do something like that. It's a bad idea. Okay. If you're going to check your output, you might need to put the drive in vector mode and turn your output phase loss to no, so that the drive will operate with no load on it. That's common too. When I think about an instantaneous overcurrent trip, I like to think about how long has the drive been running. Is it startup or has it been running for a long time? Okay. Quite naturally, I'm gonna look at the output voltage from the drive to make sure I've got a nice balanced output. And I'm gonna look and think about, is this happening at a certain speed? Did something happen? Is it conditional? Is it on a conveyance system? And we've got a backhoe, or not backhoe, but we've got an end loader that's dropping rock or coal or something and impacting this conveyor belt, which has happened many times through my life when people have just dumped stuff on the conveyor belt and actually caused an instantaneous overcurrent on a conveyor belt. Okay, you can always measure your motor current in each leg. Now, the really cool thing is with Drive Composer, you can actually connect that up through the keypads. You got a port on the keypad. You don't have to open the door of the drive for nothing. Plug your laptop up to the keypad on the door, and now I can see the motor current in each leg right there on my laptop. Okay, wicked cool. Okay, I had a job here in Nashville for Metro Water. Tommy Mullins was the maintenance guy's name over there. He's the head maintenance. I loved old Tommy Mullins. I think he's retired now. What a wonderful old guy. And he had a job over at 100 Oaks Mall. He called me on it just whirling that the drive was tripping in 10 seconds. He said, maybe not even that long. And so I went down because I live over here. So I went over to see him and actually went over just to have lunch with him too. And it was talking with him and standing there looking at it. And the motor leads, one of the leads was actually smoking. And when they tried to start it, I was looking at it, and I said, Tommy, what the hell have you done here? He had run two of the like T1 and T2 through like a conduit stub, and then he had run T3 underneath it, outside the conduit. I'm like, why did you do that, Tommy? He goes, well, I couldn't get it through the conduit. I'm like, well, it doesn't matter whether you can or can't. You can't do that, Tommy. You got to run all your motor leads together, man. So those are the kind of things that I think about. And I'm going to give you an opinion. This is a Larry Stanley absolute opinion. Most of the time when I'm thinking of instantaneous overcurrent, I want to think an application issue. Now, we all know that's not always going to be true, but instantaneous overcurrent to me, I think about my output. I think about my loading first. I think about what's going on. Do I have roller bearings out there or on a conveyor belt, and one of my rollers is frozen up? I think about things like that. Is there any chance in the world? Do you know the electrician that wired the pecker head? Do you know this person? Are you comfortable that your motor leads, that the motor's not been vibrating, and that you did maybe a poor taping job, and those motor leads have chaffed inside that pecker head, and we're starting to see something like that happen? Okay, those are the kind of things I think about. I like to think about the application itself, and then the motor leads, and I think the last thing I think about is the variable frequency drive. Okay, that's kind of how I would typically troubleshoot instantaneous overcurrent. Again, is your bypass, and is that output contactor chattering there? Okay, is the motor in a wet application or wet installation, something along those lines. Overload on startup. Let's look at the drive. Let's look at the setup and make sure that we've got all the drives, that the drive has been set up right. Who commissioned the drives? Do you know this person? Do you know that they've done a good job? Did they do the tune? Is everything done correctly? Did you measure your DC bus? Do you have a nice solid DC bus on this drive? Okay. Are your outputs balanced? Okay. Are you trying to accelerate a load up too fast? If you've got a large fan, okay, I had just a heck of a time over in Concord, North Carolina. I think it's Philip Morris over there. I had a heck of a time with those guys. They had some fans, some big fans, like 500 horsepower, and they kept on preaching to us, oh, we never use all this horsepower. So they decided they're going to put 300 horsepower drives on it because that's all they needed. Wrong. In the summertime, in the mornings, that air was wet and heavy, and they absolutely could not get it moving with 300 horsepower with the motor. And the drives would go down on overload. Then once they got the air moving, we had a problem with those guys because the air wanted to stay moving, and we'd get an overbraking fault or a bus overvoltage fault. So we had to think about things like that. Overload, very typical. I'm going to look and see how I've got my drive set up. I'm going to look and see how fast I'm trying to accelerate it. I am going to look and see what kind of application I got there. Okay. And then I'm also going to start looking on the mechanical side. How many motor leads do I have in my tray or in my conduits? Am I having a problem with that? If I have an O-scope available, it's always kind of nice to look at your voltage waveform to see what your voltage looks like coming into the drive. Especially if you got an application where you're having some current problems at the higher ends. Maybe I'm getting a little bit of flat topping on that input, and I'm a diode input drive. Maybe I'm using diodes in the front end. I'm using the traditional old 6-pulse diode front end drive, or an old 18-pulse, and I'm flat topping a little bit coming into the drive. That's one of the really neat things about an active front end drive or an ultra low harmonics drive. We're not so dependent upon that shape of that that voltage waveform coming in. Ground fault, and I apologize for talking fast. I'm just trying to get everything in for us here today. Ground fault, I always like to look, and my daddy was a coal miner, so I always like to look and see if my motor leads are going up or my motor leads going down. In the coal mines, you know, you have to worry about water because everything seeps to its lowest point. So I always like to look and see if my motor leads, if conduits are going down. Then one of the first things that comes to mind is I think about moisture in the conduit. Subsidence can cause conduits to break, and I can have water in the conduit. Are there multiple motor leads in the conduit? How long is that motor lead? Okay, what kind of conductor? Did I use THHN conductors? Okay, what is going on that I could be having a ground fault problem? And friends, let me tell you something. If that drive goes down on ground fault, don't waste your time troubleshooting that drive. You start looking from that motor lead out, because a drive, if it can't do anything, it can do a fabulous job for ground fault. So if you're getting a ground fault trip, don't start by looking at the drive. You start on that motor lead out, to the field, not the drive itself. Okay, that'll save you a lot of time. Ohm your motor leads out, meg your motor through the motor leads. Unbalanced currents, you remember, we are voltage sourcing, current regulating. The motor is going to draw current based on the value and the design of the motor. That's what's going to dictate the amount of current that you're going to see in each one of them motor leads. If the currents are greatly unbalanced, okay, absolutely, go back, drop your motor leads. Let's look and make sure that everything looks good coming out of the drive. But if those currents are unbalanced and the voltage is good, it's in the application. It's in the motor leads or the motor itself. You're not going to find it in the drive there then. And this is common sense. Let's look for lugs discolored. If you're going, if it's not a great big huge motor and it's easy to pull the pecker head, of course, pull the pecker head. Let's look and see what's going on inside there. Make sure our taping and everything looks okay there. Okay. Make sure that we don't have something going wrong. Make sure that the motor was wired correctly. Okay. Check the motor itself. I like to recommend that you meg at 1,000 volts so that we stress the dielectric content of the motor winding. Okay. Over voltage, very common trip. Power factor correction capacitors, lightning strikes. On the weekends, we've had through the years, I've seen sites where the voltage goes high on the weekends. It'll travel up 500, 515 volts and cause a problem with the over voltage. If you're in the fan world, in the HVAC world, if I've got a large fan and I'm trying to bring it down too fast, okay, that's a real easy way of causing an over voltage, controlled by the deceleration ramp. If I'm in industrial, have I tripped my circuit breaker, my fusing in my dynamic braking circuit, okay? In our drives, we can extend the ramp time by auto decelerating so that we watch the rate of the rise of the voltage on the bus and we start to extend that deceleration ramp. That might be something you want to set up inside the drive. Fault histories is a great place to go, okay? Let's look and see what all is happening in the drive. Make sure that you're looking at all the faults. And really and truly, fault history is great if you're coming in on Monday morning and you see that the drives are tripped on over voltage. Now you can look and see what the level is and see if it's consistent. See if I'm consistently tripping at 5:43 in the morning, okay? Then I know right away, oh man, I need to be looking for power factor correction capacitor switching, okay? Things like that. Resetting a fault, you can have auto reset on a fault, okay? I would always recommend that you mark the drive, that the drive might restart without human intervention. So those are the kind of things that I think about there. There's a lot to look at with the drives for, like accelerating too fast, decelerating too fast. So a lot in the setup of the driveway. Remember, let's vacuum the drives out. Don't blow the drives out. Let's use type 12 enclosures when we can to keep the nastiness out, and the fan filters go on the output of the drive.